will use the information from this graph to solve the next two questions. And this graph is about the US population sex ratio from year 1900 to 2000. And the graph is about the number of males population for every 100 females population. And we can see here that from the graph we have a horizontal line with number 100 on the left side, and this horizontal line is telling us that we have a number of males population for every 100 females population, and we can find the number of males population above this vertical bar or below this vertical bar. So this number is telling us the number of males population for every 100 females population. So by having these two numbers, or the number of males population for every 100 females population, then we will have the ratio of females population to males population in every year. For example, in 1900 we have the number of males population for every 100 females population is 104.4. It means that the ratio of females population to males population is 100 to 104.4. And the same information we can get the same information for the other years. And what about this upward bar and this downward bar telling us? This upward bar and this downward bar is then telling us the difference between the females population and males population for every 100 females population. So for example, in 1910 we have the ratio of females population to males population is 100 to 106. It means that for every 100 females population, the difference between males population and females population is 6 people. So if we have a higher bar, it means that the difference is higher, and this upward bar is telling us the positive difference, and this downward bar is telling us the negative difference. So if we have a positive difference, then the number of males population is greater than the number of females population. And if we have a downward bar, it means that we have a negative difference, or in other words, the number of males population is less than the number of females populations. So we have those two informations from this graph. First, we will have the ratio of males population to females population for every year, and we will know the difference between the males population and females population. We can see how much the difference is changing for every year from this graph. And now we can solve the first questions. And the first question is, to the nearest 10 of 1%, in the year that males made up the smallest percent of the population, what percent of the population was female? So in this problem, we want to find the percentage of the population of the female population in a year in which that the male's population is the smallest percent of the population. So we want to find a year in which that the male's population is the smallest percent of the population, or in other words, the male's population is of course less than the female's population. Therefore, the first 5 years here will not be the year for this problem. Therefore, we will look for the next 6 years. Since we want to find the smallest percent of the male's population, it means that the difference between male's population and female's population should be the highest, or we should have the highest negative difference between the females population and males population. Therefore, the year that we will use for this problem will be in this year, in this 1980, because in this year we have the longest downwards bar. So in 1990 we have the number of males population for every 100 females population is 94.4. So for every 100 females population we have 94.5 males population in 1980. It means that the ratio of females to males population in this year is 100 to 94.5. And since we want to find the population of female, or the percentage of female population, so we need to find the ratio of the females population to the total number of population in that year. Since the ratio of females to males is 100 to 94.5, therefore the ratio of females to the total population in this year will be 100 to 194.5. So the total population will be the sum of these two numbers. And if we want to find the percentage of the female population, we just need to multiply this ratio by 100%. Therefore, using our calculator, we'll get that the percentage of the female population will be 51.4%. Therefore, the answer for this problem is D. The second question, if in 2000 the population of the United States to the nearest million was 282 millions, which of the following is closest to how many more females there were in the United States than males? So we want to calculate how many more females than males in 2000. In other words, actually we are asking to calculate the difference between male and female in 2000. So from the graph of this problem, we have the ratio of males and females in every year, and we can also calculate the difference or the ratio of the difference between male and females to females. But since we are given the total number of the population, we need to find the ratio of the difference between male and female to the total population. So if we take a look on our diagram, in 2000 we have this number. It means that we have 96.3 males for every 100 females. It means that for every 196.3 population, the difference between male and female will be 100 minus 96.3, which is equal to 3.7. By having this sentence, it means that the ratio of the difference between male and female to the total population will be 3.7 to 196.3. So since we are asking to calculate the difference between male and female, we can find the difference by multiplying this ratio to the total population in 2000. So the difference between male and female in 2000 is the product of this ratio to 282 millions, and using our calculator we get that the result is 5,315,333.67. So this is the difference between male and female in 2000, and the closest number of this result is 5,300,000. Therefore, the answer for this problem is B.